-1, -4 is a terminal point of angle theta in standard position. So when we learned about what an angle in standard position is, that was important. If we draw a picture of this, -1, -4 is right there. If we have an angle in standard position that goes to that arm, wow, that's not a very straight line. Try that again. That looks better. That would be the angle in standard position that ends with a point at -1, -4. This is the information that you're given, and the question's asking you to find the exact values of the 6 trig ratios. So we want to find out what is sine of theta equal to, cos of theta, and tan of theta, and also all the reciprocal ones. And this is the only information we've got. We've got that the angle ends right here. Well, if we think back to sine, cos, and tan, and the first time that you learned it, you're going to remember the definition of sine was the opposite over hypotenuse. The definition of cosine was the adjacent over the hypotenuse. And the definition of tangent was the opposite over adjacent, or SOHCAHTOA. Is probably what you use to remember it. Now, in order to use SOHCAHTOA, what kind of triangle do we need? We need a right-angled triangle. So a lot of these questions that we're going to do that are going to ask you to find things about sine, cos, and tan, I'm going to call them triangle questions. Because the main strategy that you're going to use to solve this question is to draw a triangle. And the triangle that you're going to draw is the triangle back to the nearest x-axis, so that in your triangle you will always have the reference angle for your angle in standard position. Does it make sense that that green angle is your reference angle for the angle theta? Because your reference angle is always the angle back to the nearest x-axis. And so if you draw that triangle, and this will be a right-angled triangle, now we have a triangle. What can we label on that triangle? Because we have the point, how long is this side here? 1. How long is this side here? 4. If you did a squared plus b squared equals c squared, how long is the hypotenuse? Square root of 17. And you will get so good at doing all a squared plus b squared equals c squared in your head just like that. So you're going to go 4 squared is 16. 1 squared is 1. 16 plus 1 is 17. So my hypotenuse will be the square root of 17. Now, the key thing about reference angles is that sine, cos, and tan of the reference angle will be the same as sine, cos, and tan of the original angle, except maybe it changes from positive to negative. But the ratio itself will stay the same. So if I look at my reference angle and I say, what sine of theta, or what sine of the reference angle in that triangle? Well, sine is opposite, which is 4, over hypotenuse, which is root 17. And I'll figure out my sine ratio. But because it's in quadrant 3, right, and according to our cast rule, what do we know about sine in quadrant 3?
It's negative.
It's negative. So we then have to do that in the end. So we can use our triangle to find out the ratio. Has to be 4 over root 17.
Can you just keep the negatives, or is that?
We can, although I like actually labeling things as an actual triangle, because it doesn't really make sense that this length is a negative number. I mean, it's negative as in the fact that it's going down and it gives it a direction. But I like to use positive values when talking about a triangle, because then you can go back to your grade 10 trigonometry and just basic trigonometry. And then in the end, check to see, should it be positive or negative. And I like doing that check at the end because it just gets you in the habit of checking things. Nice thing about grade 12, in grade 11, if you had a square root of 17 on the bottom, you would have to rationalize the denominator. In grade 12, they assume you know how to do that, and so they say, don't worry about it. You can leave your answer with the square root of 17 on the bottom. You do not have to rationalize. But you have to know how to do it for multiple choice questions, because it might be the answer is rationalized. But if you're asked to find sine of theta, you could leave your answer like that, which is really nice. Going to cos, cos is adjacent over hypotenuse. So here we would have 1 over square root of 17. Again, cos positive or negative in quadrant 3? Negative. And finally, tan, opposite over adjacent, and tan would be positive. You could just write 4 if you like, because 4 over 1 is 4. But I wanted to show that I did the opposite divided by the adjacent. So if you left it as 4 or 4 over 1, again, in grade 12, both of those would be fine. When we go to the reciprocals, if you know sine theta and you know that cosecant is the reciprocal of sine, to write the answer for cosecant theta, all you have to do is flip that fraction. Or you could remember the Cho-Shikao. No, I don't think.
No, it's
Something like that.
don't you tell us you can never use us.
No.
It'll be in our test. It's going to be Chosakawa and Sokotoa. I don't know which one it is yet.
No, just use Sokotoa. And then take your answer. So for cos, negative 1 over root 17, it's going to be negative root 17 over 1. We just do the reciprocal. And notice where sine is negative, cosecant's negative. Where secant is negative, cosine is negative. So if tan is positive, cotangent will be the reciprocal and positive. So to recap, if we're ever asked to find sine, cos, and tan, chances are a very good strategy will be to draw a triangle. And a lot of questions we're going to do this year, that will be a strategy we're going to use. So if you come for help, it might be the first thing that I say, oh, it's a triangle question. Have you tried drawing a triangle? And then once you draw that triangle and label everything that's given to you, you might see that it's easy to figure some other stuff. Like it's usually easy to figure out all the sides using a squared plus b squared equals c squared.
So when you figure out the angles of it, the exact angles in the third?
In this question, there's nothing asking us about the exact angle, but we will get questions that will, and that's in our example 4, where we're asked about the angle. But again, by drawing the triangle, it's going to be so easy to find that reference angle because that goes back to your grade 10 trig. If you wanted to find the reference angle, can you see that you could do tan inverse of 4 over 1? And that would get your angle. And then since you know your reference angle, here you just have to go 180 degrees plus your reference angle and you'd find your actual angle. And the picture really helps you see that. So drawing the triangle helps you figure out the values. Drawing the triangle will help you figure out your reference angle. Once you have your reference angle, the entire diagram would help you find the angle. Okay, so try number 8 right now. Just work at it quickly.